LATERAL SAFE is a prevent project which introduces a cluster of safety applications contributing to the prevention of lateral and rear-related accidents. Prevent is co-funded by the European Commission under the 6th Framework Programme, being one of the largest e-safety initiatives. Prevent develops and integrates preventive safety systems to save lives by reducing vehicle accidents. Preventive and active safety makes use of sensor data, communication, map and positioning technologies in order to provide solutions for improving road safety. Lateral SAFE is aiming to support the driver by decreasing the risk of collisions in the lateral and rear area. 3 applications have been developed to address this: the lane change aid, the lateral collision warning, and the lateral and rear monitoring. The lateral SAFE is expected to be a key component for future multiple ADAs, as the lateral and rear area of the vehicle is responsible for a large percentage of the overall accidents and especially the fatal ones. These imply that functions able to support the driver in cases of lane change or to warn the driver when other objects are approaching the vehicle from the lateral area could strongly contribute to the reduction of related accidents. Different sensor technologies are needed to be integrated today in the vehicle in order to cover all the area around it and to provide complete support in all traffic and environmental scenarios, and in particular in urban congested situations. As every other prevent project, Lateral SAFE follows a layer-based architecture which includes the sensor, perception, application and action layer. Based on this architecture, Lateral SAFE produces a multi-sensor open and reconfigurable platform which allows the implementation of its applications. The objectives of Lateral SAFE are to enhance drivers' perception in lateral and rear area by decreasing the risk of collision in lateral and rear area, the extension of current operative ADA's functionalities by operating in case of high-speed approaching vehicles in highways and by extending the blind spot detection down to 0 km/h in urban areas, the development of a reliable data fusion algorithm, the selection of a proper, reliable and flexible sensor array, and the design and implementation of appropriate HMI and warning strategies. Three 24 GHz short-range radars, SRR, from each side cover the lateral area of the vehicle. The network of the SRR covers the lateral area of the vehicle up to 30 meters and each radar's field of view is 80 degrees. A 77 GHz long-range radar, LRR, covers the rear area of the vehicle at 150 meters maximum distance with a field of view of 16 degrees. A set of cameras form a monovision and blind spot system which provide highly accurate and detailed information about the objects around the vehicle and their dynamics. Also, an innovative stereo vision system is investigated in laboratory situations. The role of the perception layer is to carry out perception enhancement tasks independent of the application, describe in a formal way the environment and the traffic scenario, support lateral SAFE functions under request, act as a gateway between sensor systems and applications with defined interfaces and I/O protocols. The perception layer modules are long-range radar tracking, short-range radar network signal processing, synthesized vision image processing, and data fusion. Lateral SAFE sensors cover completely the rear and the side area of the vehicle, the system's processing modules to provide a precise representation of the vehicle's environment to the applications. In order to combine information from the various sensors used, data fusion algorithms and synthesis techniques for obstacle detection and tracking were developed and tested. The images are captured by 3 cameras. 2 are positioned in the side mirrors, and 1 is located at the rear window. In real time, image information is processed and merged into a single synthetic view of the situation beside and behind the vehicle. It is subsequently transferred to the data fusion. In order to combine and exploit information from the various sources, fusion algorithms and data synthesis techniques for obstacle detection and tracking were implemented and integrated to the system. The action layer includes the human-machine interface HMI devices. Research has been carried out so as the HMI to not overload the driver, but at the same time to provide the necessary information and draw the driver's attention to the direction of a detected threat. For this purpose, visual and sound warnings were designed. The lateral safe HMI devices include a central rear view mirror with LEDs activated in different number and colors depending on the danger level related to the collision time for the LRM application. External side mirrors with integrated colored LED icon in two colors depending on the assessed danger level for the LCA and the LRM applications. A narrow type light integrated in the A-pillars indicating the possible presence of lateral collision danger situations for the LCW applications. Car speakers and audio control devices to complement the visual warnings with directional acoustical warnings in case of imminent collision risk.